Woohoo! We are live. This is Math 60, and we're going to be doing 3.6, and it's just a bunch of word problems. So, a couple things when you get ready for word problems. Have lots of colors available in case you need to color code. Have your friends close by in case you need some support. Have a calculator because sometimes the real world problems don't work out very nicely. And then pen or pencil and a lot of patience. And I will keep saying, but problems in math, especially in Algebra 1 or Algebra 2, should not be taking you half an hour. So if you're working for half an hour on a problem, take a break, get some help, ask your friends, ask the tutors, ask me, go to Khan Academy, go online and Google it, get all the help you can, collect everything, see if you can figure it out. And if it does not become clear, again, feel free to be brave and come ask me. You'll be surprised. Sometimes I can actually give you the answer you're looking for. Sometimes this is the teacher you're looking for. Okay, so let's get started. These are going to be problems that you can solve using two equations. So this may even be problems you've done before, but in a different method with one equation. So I'm going to be hopefully showing you some new stuff because that's the whole goal. Let's get started. A total of $10,000 was invested in two accounts for 1 year. So there was 10 big pile of money and it went into two different accounts. If the first account earned 5% and the second account earned 25%, at which point you should be asking me, whoa. Why are you going to bother with 5% when you can earn 25%? And I'm going to tell you, if someone's offering you 25% interest, that means it's a very risky, very dangerous investment. Interest rates are effectively a way to pay you. It's a way to compensate for how risky something is. If there's an investment that's going to pay off 25%, there's actually a pretty good chance that you will, in fact, lose all your money. So you don't want to put it all in there. You want to put some in the much safer investment, so you're balancing it. Sometimes people call this diversification. There's also a phrase, don't put all your eggs in one basket. So we're going to figure this out given those two investments. And we know that the investments earned a total of $1,500 together. How much was invested in each account? So the first thing I'm going to say is this is definitely an investment account, investment problem. And so I'm going to call up the investment formula. I, the interest, equals PRT, or simple interest equals principal times rate, sorry about that, Apple guy, times time. Okay, I also happen to know that this problem is a mixture problem. Now, why am I saying that? Well, this is this case where we're taking two piles of money. Each of them is earning interest, and then we're putting them together. That's a mixture problem. Whenever we've got two things happening that we're going to put together, it's going to be a mixture problem with one caveat. If something is moving, if it's a distance rate time problem, it's different. But all the others are going to be mixture problems. And so a mixture problem, generally speaking, is going to lend itself pretty well to the chart. Now, if you've been attending classes at City College for a while, then you'll know we love charts. Woohoo, we love charts. I've got 4 rows, and in my first column, and I know this is weird, but in the first column, we usually just scratch it out. I'm putting a smiley face so we can feel positive about this. So how are we going to do this? Well, in the next 2 columns, I'm going to write down the things that we're going to add. We're going to add a 5% investment and a 25% investment. So this whole row is 5%, this whole row is 25%, and at the bottom, I'm going to write the mixture or the blend. And the word mix fits, so I'll use that. Now, the chart is primarily for you to help you organize your thoughts, to help you write down all of your information. Because if you leave it here in the sentence, in the problem, what happens is you start reading and then you get sucked in. You get into that spiral and you never pull out. So this is a way to take all the information and put it right here where we can use it. Okay, so that's the first column, is just an identification of the rows. Next up, I'm going to look at this formula and I'm going to twist it around a little bit. I'm going to say the first thing I want is P. So what is P? Principal is the money you start with. Oh, that looks funny. Sorry. Let's try that again. You start with. So the principal is the money you start with. So does it say how much we're going to invest at 5%? No, it does not. Does it say how much we're going to invest at 25%? No, it does not. Does it say how much we are going to invest altogether? Yes, it does. A total of $10,000. So that's going to go down here in the mixture. So I know that's $10,000. Okay. Interest rate. Now here, I've already got the rate, 5%, although I'm going to write that as a decimal because percents really don't play well with algebra. 0.05. Okay, 25%. Let's convert that to a decimal. You got it, 0.25. Now it turns out that we can figure out the interest rate for the mixture, but we don't need to. I'm going to leave that blank almost always. Now, if you're curious, I can show you how to do this. It's pretty straightforward, but it will not help you solve this problem. I just happen to know that. Okay, so I've got the P and the R. I need the T. These three get multiplied together to give me the interest. So how long are we going to be investing? And I see an answer to that right here for 1 year. And that's going to govern the whole thing, and that is that this is 1 year. 1 year, 1 year. And the great thing about this is this matches this, because when we say 5% or 25%, it means per year. So the fact that these are each 1 year, that means all of the units agree. It's lovely. Okay, so, and then do we know anything about the interest? And I do see another number right here. I see $1,500. Where does that go? What is that? Is that the 5% interest? Is that the 25% interest? You're right. That's actually the total interest, so that goes down here. $1,500. And this is really good because we already have dollars over here, so the fact that we also have dollars over here is really good. Okay, so at this point, I double check. I say, okay, I got the 5%, I got the 25%, I got the 10,000, I got 1 year, I got 1,500. I've used all the numbers. So the only thing left is now to assign some variables for the things we don't know. Generally speaking, I'm going to assign variables over here on the left, not here on the right. Here on the right, we're going to be able to do some magic, but over here on the left. So let us say, and I think a lot of students right off the bat want to use X and Y, so I'm happy to use X and Y. I'm going to say, let's say X dollars is invested at 5% and Y dollars is invested at 25%. Okay? And if that's true, then we've got a formula we can use. The simple interest in each case is going to be the principal times the rate times the time. So X times 0.05 times 1 which ends up being 0.05x. And then here, y times 0.25 times 1, y times 0.25 times 1 is 0.25y. And I hear some people in the audience saying, wait a minute, why are you multiplying? And the answer is because the formula says we multiply principal times rate times time. Woohoo! And that gives us simple interest. So I multiply across. Now I'll tell you a hint. Mixture problems, the ones that we're going to focus on, as you move across, the formulas are almost always multiplication. And then there's another thing that happens, and that is that as you move down, because of the nature of mixture problems, you're going to add. So get used to the multiply across and add down. I hear some people asking, ugh, I hate charts. Do I have to use it? No, you don't have to use it. However, the benefit of the chart is that anyone reading the chart sees immediately what's going on. And it's very clear, like I know X is the amount you invested at 5%. If you do not have your chart, remember to declare variables. Oh, I am having trouble with my language tonight. You can tell this is being recorded very late. If there's no chart. So what does that look like? Let X be the amount invested at 5%. And then here I love using ditto marks. They're my favorite. Let Y be the amount. It means copy the same thing down below at 25%. Ooh. So that's what declaring variables looks like. And this is, if you don't have a chart, you need to tell me what your variables are. So it's the chart or declaring, or both if you feel like it. Okay, so I've got the chart though. And now I'm going to use the chart. And I'm going to say, if I look at this piece of the chart, if I look at the column that has the P in it, oh, that didn't sound good at all. But you know what I mean. I see that the total amount is 10,000. That's made up of X and Y. So X plus Y must be 10,000. And that I get from my first column, that P column. Okay, notice that I do not write the dollar signs. You do not put, in math, you do not put units into equations. In other fields, you do put units into equations. Okay, so next up, I'm going to, I can't add, you cannot add interest rates. 1 year, 1 year, 1 year doesn't give me much. But then interest, the I column, let's do that in orange. And the I column gives me 0.05x plus 0.25y equals 1,500. And again, no units, no dollar signs. Okay, what do you think? So far, so good? At this point, I've got 2 equations. Woohoo! So what do we do now? We solve those 2 equations using the techniques that we have in the rest of chapter 3. So let me copy this over. This is 1. Continued. So I've got X plus Y equals 10,000. And 0.05x plus 0.25y equals 1,500. Okay, so now what do? Well, now I have to come up with a way to solve this. Again, some people can get to these 2 equations without setting up the chart at all. So if you want to do that, that's fine. Just remember to declare your variables. And then Some people can go ahead and solve this without doing what I'm about to do, but I am about to do it. I'm going to multiply the bottom equation by 100. Why is that? That'll move the decimal point 2 places. So I get 5x plus 25y equals 15,000, so 150,000. Now looking at that, I'm aiming for elimination. Now you guys could, given that there's an x plus y, you could use substitution on this one, but I'm going to use elimination. So I'm going to multiply on top by a -5. What's that going to do? Well, -5 times x gives me that -5x. That's how I'm going to get things to cancel out right here. Minus 5y equals -50,000. So then let's add. This becomes 0 x's. This becomes what? You got it, 20y. And this becomes, you got it, 100,000. So then 20y over 20 equals 100,000 over 20. Now, when there are this many zeros, I would try to do this in my head, and that's awesome, but I'm also going to double check it. Divided by 20 equals y equals 5,000. Awesome. So do we know what x is? Yep, because x plus y was 10,000. So 5,000 for y. I subtract 5,000 from both sides. I get x equals $5,000. So then at the end, I can just write x equals 5,000. Remember to use units. Y equals 5,000. And then anyone reading the paper would be like, wait, which is which? You can go right back to the chart and see that x was the 5%. This is 5% and this is 25%. Now, is there a way to check word problems? Not generally. Could you plug these two values into each of these? Absolutely. I'm actually going to go a little more directly. I'm going to double check. Total of 10,000, yes. And do we get 1,500 together? So let's check the interest. Okay, so x was at 5%, so 0.05 times 5,000 times 1, 0.05 times 5,000 is 250, and 25% of 5,000 for y is 1,250, and if we add them together, we get 1,500. That's the interest they were supposed to earn. We got it. Now, can you always check word problems? No. A lot of times you're just going to have to use your best guesstimates. So, and I will show you a little bit more as we work through the problem. So for this section, you know, these are all word problems. They're all going to take a while. So I would go ahead and, if I were you, assume there would be only one or two problems per video. I'm going to cap it here. We're at almost 19 minutes. And then I will see you for number 2. Woohoo! Math on, guys.